Hello everyone, welcome back to my YouTube channel. In this particular video, we'll perform the data visualization onto our dataset. In the previous video, we already have seen the data pre-processing. We have seen multiple techniques to clean the data. I hope you have seen that particular video. Now, in this particular video, to plot multiple interactive graphs, we are going to use the Plotly library. And for installing the Plotly module, you just have to run this particular command. That is pip install Plotly. And if you execute this, the library will get installed. Now, since the library is already present inside my Google Colab notebook, hence it is showing requirement already satisfied. So you can see it has got executed. Now we will import the Plotly module. We'll specifically import the express from the Plotly module and we'll give it an alias as px. So now we know our dataset. Our dataset contains total 11 features and one target column. So let me first print one sample data of our dataset. So heart df dot sample and let's print it. We'll get one sample and you can see over here we have these many columns. First we'll try to figure out the relationship or the correlation among these columns. Specifically, the correlation between every single feature column with the target column. So to get the correlation, we know that we can easily get it with the help of the dot corr function. So heart underscore df dot corr function is going to give us the data frame in which the correlation values will be printed. The value which has a negative sign depicts that the two features are negatively correlated among each other, and the value which has the magnitude more than 0 tells that it is positively correlated. The correlation value among the features whose magnitude is 0 tells that they are having no correlation with each other. You can see over here that the heart disease column is having these many values, which says the correlation of age. The first value says the correlation of age column with the heart disease column. It says that it is positively correlated, but it has a slight positive correlation because it is near to 0. 0.28 is near to 0, which is lesser than zero point 0.5. It has a positive correlation, but it only has a slight positive correlation. So now these values might be confusing. So let's see all these values visually. So for doing that, we have this particular line chart inside the plotly.express module. And here we are going to give the heart underscore df dot correlation. And since we only want the correlation of all the features with only the heart disease column, we'll write this heart disease. And let's try to print what we get with this. So here you can see we are getting all these values. This is nothing but, if you remember the previous data frame, this is the last column. Now, we don't want the correlation of heart disease with heart disease itself in the line chart. So we can get rid of it with just one single step by writing this particular code. So slicing this will slice off the last value, that is the heart disease, and we'll be left with only these many values. So let's print this and let's see whether we are getting rid of the heart disease column or not. So yes, we are getting rid of that particular heart disease value. And we'll put this inside this px.line. With that, we'll also sort the values. Now this is completely optional. Sorting these values will sort all these values based on its magnitude. So let's try sort underscore values. So you can see least value here is zero point 0.4, which is having a negative sign, minus zero point 0.4, which is max HR. So max HR will come first. So you can see it has got sorted in ascending order. So I have written this inside the px.line chart. And now let's print it. Let's execute it. So here we are getting, okay, we haven't executed this particular step. So here you can see we have executed this particular cell, and now we are good to go for executing this particular line. Let's execute this. And here you can see we have got a line chart. You can see that this particular line chart is having on the x-axis all the features, and on the y-axis it is having the correlation values. Here you can see that max HR is having the least correlation, or I would say it is negatively correlated with the heart disease column. The sex feature is again negatively correlated. When we talk about resting ECG, it is having a positive correlation, but it is nearly equal to zero. So we can say that resting ECG is having almost no correlation with the heart disease column. Similarly, we can see that cholesterol is again nearly equal to zero. Its value is nearly equal to zero. So we can see that cholesterol is also not having any correlation with the heart disease column. And if you see the last value, which is ST underscore slope, it has the highest correlation with the heart disease column, which says that it has a positive correlation. So I hope this particular plot is clear. Now let's move on to the another. Now let's move on to the another plot that is going to give us the relationship with age and heart disease distribution. So for that we are going to use the sunburst. So you can see what is this sunburst plot. A sunburst plot represents hierarchical data as sectors laid out over several levels of concentric circle. So we'll be using this sunburst plot, and how it works, we just have to pass the data frame, and then we have to specify the columns for which we are going to plot it. So inside the path variable, and we need to give it in the form of list. So we want the heart disease and each column relation. So let's print it. So here you can see how we are getting this particular plot. You can see we have these two labels. One means there is a presence of heart disease, and zero means the heart disease is not present. So if we specifically click this one, that means the heart disease is present. It says that more number of patients are having heart disease whose age is 58. There are total 28 patients who are having their age as 58 and are having heart disease. Similarly, you can see 57 is the next age value. Then we have 61, then 56. So in all, you can summarize here that the patients whose value is nearly equal to 60 are having higher chances of getting heart disease. So this is how this sunburst plot is useful in summarizing things. Similarly, if you look at this particular label, which says that heart disease is not present, we can see that most of the people are having their age lesser than 55. So if the person is having the age lesser than 55, there are less chances that the person will get heart disease. So this is how the distribution goes with age and heart disease. So now let's move on to the next. Here we are going to print the histogram, which will have the age, and it will segregate it with the help of the heart disease values. So let's print it and let's see what we get. So here you can see the age is on the x-axis, the count of the patients are on the y-axis. So here you can see the red one is the one uh, which has the heart disease, and the blue one is the one which doesn't has the heart disease. So if you only look at the blue ones, that is, there is no heart disease here. So here you can see the patients with the range 35 to 60. These are some of the patients which are higher in number and they don't have heart disease. And similarly, if we look for the red one, so here you can see patients with age more than 45 are having more chances of getting heart disease. So this is how we can analyze this particular thing. So I hope this is clear. Now let's see the distribution graph of percentage of heart disease. That means we are going to plot the pie chart. We are going to look how many values we are having where the heart disease is present and how many values are there where the heart disease is not present. So let's plot this pie chart. So for plotting this, we just have to write px.py and then we need to give the heart underscore df data frame. And inside the names variable, we need to specify for which column we want distribution to be plotted, and then we can set the title. So let's plot this. Here you can see that 44.7% of the data contains the value 0, that and 55.3% of the data contains the value 1. So here you can see that the data set is not imbalanced. So let's move on to the next. So now we'll see the distribution or the relationship between the sex versus the heart disease column. So for that we are going to plot the histogram. So basically, if you remember, the sex column had two values, male and female, and the heart disease has two values, 0 and 1. That is whether it is present or not. So let's plot this histogram. So in this histogram, we are getting such scenario. So just focus here that on the x-axis, we have two values, 0 and 1, which says the sex of the patient. That is 0 for male and 1 for female. So if you don't remember, let me show you what values we have given for the sex column. So here you can see that male and female are having the values 0 and 1 respectively. Let's come back to this particular graph and see. You can see if we only look at males, so inside this we have two things. First is the red one and the blue one. Inside the red one, it says that the heart disease is present, and inside the blue one, it says that the heart disease is not present. So by looking at the proportion, we can clearly see that in males, there are more chances that the male patient can have a heart disease because the proportion is more for the presence of heart disease. And if you look only at the female graph, so here you can see by looking at this proportion, we can clearly see that there are very less number of females who are having heart disease. So if the patient gender is female, so there are less chances that the person will have heart disease. So this summary we can get by looking at this particular graph. In reality, the scenario might be something else, but for this particular data, the scenario is this. So I hope it is clear. Now, let's move on to the next column relationship, that is the chest pain type versus heart disease. So for this, we are going to plot the histogram. So here I've written in comment that the chest pain type had four values, that is ATA, that is atypical angina, for which we have given the value 0, then non-anginal pain, for which we have given the value 1, then we have asymptomatic, and then we have the typical angina. So we have these four values and we are going to plot histogram for these four values against the heart disease. So let's plot it and see what summary we can get out of it. So here you can see that on the x-axis we have the chest pain type, and on the y-axis we have the count of the patients who are having the particular chest pain type. 0 here, it means it is atypical angina. So if you only look at the 0 bar, here you can see there are two values. One is the presence of heart disease and another is that the heart disease is not present. So by looking at the proportion, there are more number of patients for this particular type of anginal pain, that is atypical angina, who are having no heart disease, which says that if you have a typical anginal pain, it doesn't say that you have high chances of getting heart disease. So this is what is the summary that we are getting for this particular bar. Similarly, if we shift to the next, has which has the value non-anginal pain. So what it says that if you have non-anginal pain, then there are less than 50% chances that you will be having heart disease because more number of patients here are safe or they don't have heart disease. But if you shift to another one, another bar, here you can see it is asymptomatic type of chest pain. By looking at the graph, we can clearly see that if you have a symptomatic type of chest pain, then it means that there are a lot of chances, there are high chances that the patient will have the heart disease. Because by looking at the graph, you can see that more number of patients here who are having asymptomatic anginal pain are having a heart disease. If you look at the last bar, which has the patients who are having typical anginal pain, here the proportion is almost 50%. That means if you have typical angina, it doesn't say clearly that you have heart disease or not because the proportion is 50%. So, to summarize this, we can say that if you are having a symptomatic pain, then it's dangerous. The patient is having high chances that the patient will have heart disease. So, this is what is the summary that we get by looking at the relationship between the chest pain type and the heart disease. So, now let's move on to the next column, relationship. So, here let's move on to the resting blood pressure versus heart disease. So, if you remember, resting blood pressure had numerical values. So, let me tell you what all values were present. So, heart underscore DF of resting blood pressure. And if I try to print the unique of them, so let's see how many values we have. So, here you can see there are these many values which are unique in resting blood pressure. So it's a numerical column. For that, we are going to use the sunburst again. So I already told you how to use it. Inside the sunburst, you need to pass the data frame and then you need to pass the variable path. Here you need to give the list of the columns for which you need to print the relationship. So here we want the relationship of heart disease with the resting blood pressure. Let me print this. So here you can see that we are getting this particular sunburst graph. So if we specifically look at the label 1, here you can see 140 is the blood pressure value for which there are more number of patients who are having heart disease present, uh, who are having heart disease. Now, if we look at the 10 nearest values, we can say that patients who are having blood pressure count more than 110 are having higher chances of getting heart disease. Now, if we look at the next side, that is the label for which the heart disease is not present. If we look here, if we carefully look the 10 nearest values, again we can conclude that the patient who are having blood pressure count more than 110 are having higher chances that they won't be having any heart disease. So doesn't this sound same what we have said for the label one? Here, in both the cases, we are not able to figure out what exactly is the effect of resting blood pressure with the heart disease. Now, we already have seen the relationship, that is the correlation value. From the graph, we can easily see that for the resting blood pressure, the correlation value is 0.118, which is nearly equal to 0, which says that it has a very slight positive correlation. Nearly equal to 0, it also says that it may not have any correlation. So this is what is the conclusion for resting blood pressure against the heart disease. It has nearly no correlation with it. So I hope this is clear. Now let's move on to the next, which will be the relationship between the fasting blood sugar versus the heart disease. So if you remember, fasting blood sugar was a categorical feature in which we had two values. One was 0 and one was 1. 0 means your blood sugar count is lesser than or equal to 120, and 1 means your blood sugar count is greater than 120. So now we are going to plot fasting blood sugar versus the heart disease, for which we are going to use histogram. So inside histogram, we'll specify the fasting blood sugar column, and with the help of color, we'll segregate it. Here, we will specify the heart disease column, which will be used for segregating it. So let's plot it. Here you can see we are getting the histogram. So if we specifically look at the 0 bar, here it says that these are the patients who are having their blood sugar count lesser than 120. We can say for this that we cannot predict whether the patient will be having heart disease or not by considering their sugar count lesser than 120. If the patient is having their sugar count lesser than 120, we cannot say by looking at it that the patient will be having heart disease or not. Because here in our data set, the proportion is 50%. Similarly, if we look at the bar for 1, here there are patients whose blood sugar count is greater than 120. So here we can clearly see that the patients who are having the blood sugar count greater than 120 are having a higher risk of heart disease, because more number of patients who are having greater than 120 as their blood sugar count are having heart disease in this particular data set. So this is what is the conclusion that we can make by looking at this particular histogram. So I hope it is clear. Now the next is the maximum heart rate column versus the heart disease. We are going to use the sunburst again for printing it. So let's plot it and let's see what exactly it gives. If we clearly see the one with heart disease, here you can see that the values 120, 140, 150, 130 are those values for which there are high chances where the patient will be having heart disease. So what are these values? These values are nothing but the maximum heart rate that is achieved for the patient. So if the maximum heart rate is 120, there are high chances that the patient will be having heart disease. Similarly, if you look at the other side, where the uh, patient is not having heart disease. So here you can see that the values such as 150, 160, 140, these higher values, if the patient is having these higher values as their maximum heart rate, it says that the patient is not having any heart disease. So if the value goes higher, it says that the chances are less to get a heart disease. If the values goes lower, it says that the chances are more for the patient to have a heart disease. So you can see that it is having a negative correlation. Now let's come back to this particular correlation plot. If you look at the column maximum heart rate, here you can see it has a minus 0.4 value for its correlation, which says that it has a negative correlation. So now we are done with the fasting blood sugar, the maximum heart rate, and now let's move on to the. So now we are done with this sunburst graph. Now let's plot one more graph for the relationship between the maximum heart rate and the heart disease. Here we are going to use a new graph which is violin plot. So here inside violin plot, we'll pass the heart underscore DF data frame. On the x-axis, we'll specify the heart disease, that is the target column. On the y-axis, we'll specify the maximum heart rate column, and we are going to segregate it with the help of the color, for which we are going to specify the heart disease column. Now let's plot this volume plot, and here you can see that we are getting this particular graph. By looking at this particular, the bulge is at a higher position in this particular situation where the heart disease is not present, and here the bulge is at a lower position where the heart disease is present, which again clarifies that if the maximum heart rate value is lesser, there are a lot of chances that the patient will be having a heart disease according to this particular data set. So I hope this is clear. We'll move on to the next column, which is old peak. We are going to plot the relationship between the old peak column and the heart disease column. So for that, we are going to plot the violin plot again. So here you can see that inside the violin function, we have specified the data frame, and on the x-axis, we have specified the heart disease. On the y-axis, we have specified the old peak column, and we are segregating it with the help of these heart disease uh, column, which will segregate it with the help of the color. So here you can see this is what the plot is. In the case if the patient is having no heart disease, the old peak value is nearly equal to 0, or it ranges between 0 and 2. So this is what is the summary. And if we talk about the case where the heart disease is present, you can see the bulge is ranging between 0 to 4. That means most of the patients will be having more than 0 as their old peak value if they are having heart disease. So this is what is the conclusion that we can make for this particular heart disease versus old peak column. Now let's move on to the next graph. Here we are going to use the column ST underscore slope versus the heart disease column. Now, if you remember, the ST underscore slope was a categorical feature which was having three classes. One is the downsloping, another one is the flat slope, and the third one was the upsloping. So, for plotting, we are going to use the histogram. So, inside the histogram function, we are going to specify the heart underscore DF data frame. And on the x-axis, we are going to specify the ST underscore slope column, and we are going to segregate it with the help of the heart disease column, for which we are going to use the color. And now let's print it. And you can see over here that we are getting this particular histogram. So here, if you see on the x-axis, we have the st underscore slope. 0 means there is down sloping, 1 means there is flat sloping, 2 means there is up sloping. If we only consider the 0, that is the down sloping, here are the patients who are having down sloping as their st underscore slope. So if we see at the graph or the proportion, we can clearly say that if the patient is having downsloping as their ST slope, then it clearly says that there are very high chances that the patient won't be having heart disease. Similarly, if we move on to the next, where the patients are having flat slope, here we can clearly say that as per the proportion, if the patient is having flat slope as their ST slope value, then in that case, there are very high chances that the patient will be having heart disease. And if we move on to the next, this particular bar, there are patients who are having their ST slope value as upsloping. So by looking at this particular proportion, we can clearly say that if the patient is having upsloping as their ST slope value, then there are a very high chances that the patient will be having heart disease. So this is what is the conclusion that we can make by looking at this particular graph. So in summary, we can say that patients with the ST slope value as flat slope and up slope are going to have a high chances of getting heart disease. So let's move on to the next. Here, the column is exercise angina versus the heart disease. If you remember, the exercise angina column was a categorical column. In this, there were values such as 1 and 0. 1 means that the patient is having exercise induced angina after performing certain exercises, and 0 means the patient is not having exercise induced angina. Angina is nothing but the chest pain. So let's see what we are going to use. For this, we are going to use histogram again, and we are going to specify exercise angina on x-axis. So let's plot it and let's see what graph we get. By looking at this particular graph or this particular bar, where the patients are not having exercise induced angina, we can clearly see that if the patient is not having any angina after performing exercises, we cannot clearly say that the patient is going to have heart disease, because the proportion in this particular data set for this particular case is almost equal. If you move on to the next, where the exercise-induced angina is present in that the patients, so here we can clearly see that if the patient is having exercise-induced angina, then it says that the patient is going to have a high chances of getting heart disease. So this is what is the conclusion that we can make by looking at this particular histogram. I hope this clears the relationship between exercise angina and the heart disease column. And also, the summary is clear to you all. With this, we are at the end of this particular video. I hope you have loved this particular video. We have seen every single features relationship with the heart disease column, that is the target column. And we also have seen the detailed summary, detailed conclusion of every single plot that we have got in front of us. If you carefully understand this entire video, I'm sure by using these simple plots, histogram, pie chart, sunburst, then line chart, by just simply using these particular plots, you can get a variety of insights from the dataset. I hope you enjoyed this particular video, and if you really enjoyed this video, then please hit like button and subscribe to my channel if you are new to the channel. Please share this particular video with your friends more and more so that they will also get benefit out of this. And also, I would like you all to connect to my Telegram channel so that if you have any queries, you can get it clear over there. If you like this particular video, please like, share, and subscribe to my channel. Also, hit the bell icon and don't forget to follow me on Instagram. Also, don't forget to join me on Telegram. Have a good day ahead.